Welcome, ladies and gentlemen, to Geometry, and welcome back from your summer vacation. Today I'm going to go through this worksheet that you had tried on your own, just to show you how some of the problems are done. Some of you just need to check answers. Some of you may need to have a little bit more help, simply because you're either rusty or last year when you learned it, it had been a while or you just didn't quite grasp it. So hopefully this will help. So I am going to start with this number 1, where it says simplify using order of operations. I like to use this mnemonic, PEDMAS, which is please excuse my dear Aunt Sally, but I actually have it as PEDMAS. Remember, multiplication and division can be interchanged as well as addition and subtraction. Okay, so when we look over here, you notice there are parentheses. That's what's first right here, parentheses. We need to simplify inside of here, right here. So we have, I'm going to write it over here, 3 plus 4, and in parentheses, I have 10 minus 3 squared. Well, I need to do the exponent before I do subtraction, again, because of order of operations. So inside the parentheses, you also have to do proper order of operations. So 10 minus 9, 3 squared is 9, or 3 times 3 is 9. And then from there, we can combine these, because again, we're simplifying everything in the parentheses first. So we have 3 plus 4 times the quantity of 1. So we have simplified the parenthesis. Now we would look to see if there's any other exponents. There's not. There was the one within the parenthesis, but we had taken care of that when simplifying within there. The D and the M is division and multiplication, so I'm going left to right to see if there's multiplication or division. I have 3 plus 4 times 1. I'm going to multiply those together next. And I'm going to actually, let me carry this up here so I don't confuse anyone. So I have 3 plus 4, and I can drop the parenthesis if I want at this point. I'll go 3 times 1, but a lot of times I tend to use the parenthesis or continue to. So I have 3 plus, and then the 4 times 1 is the 4. And then we do the addition to give you the number 7. A common mistake in this problem, actually not just a common mistake, something that happens all the time, is that people really want to add these together, 3 plus 4. But if you look at this order of operations that you're coming down, the addition does not happen until right here, and that's a long way down that order of operations. So I wrote this problem specifically because of that error that I tend to see within students' work. So looking at number 2, it says evaluate 3x squared minus 3x plus 2 when x equals 2. So I'm going to substitute this 2 wherever there's an x. So I'm going to put a 2 there and a 2 there. Oof, it looks a little sloppy, but okay, so we have 3. Instead of x, I'm substituting the 2 in, squared minus 3, again, substituting the 2 in, plus 2. Now to evaluate, we have to use our order of operations again. Oh, my smartboard is a little misaligned here. That is a parenthesis, by the way, right here. There's nothing else there. Okay, so I look inside the parentheses. There's nothing to simplify within here, so we're moving on to the next thing, which is exponents. Exponents, we have this 2 squared over here, so it's going to be 3 times 4 minus, and I'm going to do this at, well, I'll just leave this for a minute. 3 times 2 plus 2, and I can drop the parentheses because there's nothing within them. So now, and a lot of times I do use parentheses because my multiplication on the smartboard looks a lot like a subtraction symbol, which kind of freaks me out. But okay, so now we're going to go to the next order of operations, which is multiplication. We have 3 times 4, which is 12, minus 3 times 2, which is 6, plus 2. And now we can go left to right with addition and subtraction. So 12 minus 6 is 6, plus 2 is going to be 8. So my answer here is 8. And again, the answer up here was 7. Okay, now here's what's interesting about solving. This is number 3, is not a simplify, it's not a evaluate. This is a solving. Solving, you're actually doing your order of operations backwards. So you know how I had that PEDMAS? So instead of going down this way, this is the way you go when you simplify and evaluate an expression. This is the way you go when you solve, because you want to undo your order of operations. So this is simplify, you go this way, and you go backwards when you solve. So I'm actually looking at this problem. I first want to get rid of the parentheses, though. I want to distribute this -3 through, and I have a feeling everyone loves rainbowing through or distributing. So let's take care of that, and then we'll start. I'll kind of show you how that order of operations backwards works. So we have 7x. We cannot forget that that 3 has a negative in front of it. So it's -3 times 4x, which is -12x. -3 times 8 is going to give you that -24 equals 11. Then I'm going to simplify over here, and simplifying again is going to be the order of operations. So we add or subtract or combine any like terms, really is what we tend to say. So 7x minus 12x is going to give you a -5x minus 24 equals 11. Now this is where I was saying, once you start moving stuff across the equal sign, that's when you're doing your order of operations backwards. So far all we've done is simplified. We're using the order of operations. This left-hand side we've simplified to this right here. Now we need to solve it. So we're going to undo your addition subtraction. So I can add 24 to both sides to undo that subtraction. So we have -5x, and then what do we have there? 30 equals 35, and I'm going to run out of space. Holy smokes. You can tell I've had some summer off. Well, let's see, -5x equals 35. And then again, to undo your addition, or excuse me, your multiplication division, in this case it's multiplication, to undo that we divide. So -5, we divide on that side. What we do to one side, we do to the other. So we have x equals -7. Now what's nice about this is you can always check it back into the original equation and double check that it works. So if I put -7 right here, -7 times 4 is going to give me -28. -28 plus 8 is -20. So I have -20 in there. Times -3 is going to give me positive 60. And then up here, I have 7 times -7. That's going to give me a -49. -49 plus the 60, actually 60, ooh, I already forgot what it was. -7, 28, yep, is, when you add it together is going to give you the 11. Yep, I totally lost my number there. So always know that you can double check to make sure your answer is right by throwing it back into the original equation. We do that a lot during the year, so if you kind of didn't follow what I was saying there, just again, I'm watching my video time, I will definitely be showing you that throughout the year. Graphing lines. It says graph the line y equals 1/2 x minus 3. So it's in slope-intercept form. I have flash from the past, y equals mx plus b, where b is your y-intercept and m is your slope. So you're starting at -3 on your y-axis. So your b, y-intercept, is -3. So that's why I'm doing that right there. And then my slope is 1/2, which is rise over run. So you rise 1 and you run how you read, always to the right, folks. So you rise 1 and run 2. By the way, this was nothing right there. Rise 1, 1, 2. You only need 2 points to graph a line, but really it's nice to have more than one to get a nice accurate line. A line should be straight, and you know the line goes on forever versus a line segment, and that's why you need to have arrows on the end. So again, a line is forever, so you need to put arrows on the end, especially in geometry where we do decipher a lot between a line segment and a line, so you really need to be okay with that idea. Now, this number 5, here's what's interesting about this. It says graph the line 3x plus 2y equals 6. Now, some of you may want to put it in slope-intercept form, which is this form right here, because right now it's in standard form. It's not in a form that's easy to graph. So again, I'm going to say you could definitely put it in slope-intercept form, y equals mx plus b. So you would subtract 3x from both sides, divide out by 2, and there you go, graph it like we did number 4. On the other hand, when I see standard form, I instantly think intercepts. You need 2 points to graph a line, so I'm going to put 0 in for x. If I put 0 in for x right here, it makes this whole thing go away. So it's going to be 2y equals 6. If you solve for y, you end up with 3. So what you've done, if you plot that at 0, 3, 1, 2, 3, that is your y-intercept. I'm going to change colors here. I'm going to get rid of that. And now I'm going to put 0 in for y and find my x-intercept. So this was my y-intercept, where it hits the y-axis. This is going to be my x-intercept when you put 0 in for y. So I'm going to put 0 in for y up in the equation. So 0 in for y makes this go away. So you have 3x equals 6. And again, the reason it goes away is when you go 2 times 0, it's just 0, and 3x plus 0 is just 3x. So it literally is gone, and I love that. So you have 3x equals 6. Solve that, you end up with x equals 2. 1, 2. And again, 2 points is all you need to graph a line. It's 3 would be nicer, but you know what? This works pretty well. You graph your line, arrows on each end, and voila. Now, if you did do it by slope-intercept form, I'm going to say that's great. I'm going to show you very quickly, without talking too much about it, how to put this into slope-intercept form. So I'm going to have 3x plus 2y equals 6. Because again, I know everyone solves things differently. So let's just kind of double check if this is what you did to make sure you got your signs right. Subtract 3x from both sides. So I have 2y equals negative 3x plus 6. Divide up everything by 2. And we have y equals negative 3 halves x plus 3. So notice the 3 y-intercept is right there. We already have that point. And the slope is negative 3 halves. That means you're going down 3, 1, 2, 3, and running. So this is 1, 2, 3, down 3, and running 1, 2. So you end up with the same points using slope-intercept form versus the intercepts. Now, that doesn't always work that nice, but it will still be points right on that line. Remember, there's an infinite number of points on this line, and you only need 2 of those to graph that line nicely. Okay, so down here. And again, there's all those reference pages in the back of the book. Now, keep in mind, it's a geometry textbook, and they're not necessarily teaching it from scratch, but hopefully it did help jog some of that memory. Number 6, it says find the equation of the line that passes through these 2 points. Put the equation of the line in slope-intercept form. So slope-intercept form, folks, is that y equals mx plus b. So it's that form versus the standard form like we saw in number 5. Now, in order to find the equation, it is actually a 3-step process. Step 1 is you need to find your slope. And if this was a review, that's great. If this was something that, even after I do this, you're like, wow, I cannot remember this at all. I do actually formally teach this in a couple days, but let me just kind of run through it for those of you who may have just needed a jog of the memory. The slope formula is y2 minus y1 over x2 minus x1. It's literally just the difference or the change in your y versus the difference or change in your x. Now this is an xy point. This is an xy point. Now it doesn't matter which one you're saying is 1, 2. It really doesn't. Just be consistent. So if you're going to say this is 1, ooh, my smartboard's horrible. Let's say this is 0.1, then this has to be 0.2. So let's just I just try to avoid negatives as much as possible. So I'm going to, it's not going to make much difference here, but I'm going to go 1 minus 7, which does cause me to have a negative. But so I had 1 minus 7, which is this y coordinate, minus that y coordinate, over. Now, since I started with the 1, I have to start with the 5 here. So we chose this to be our first point. So 5 minus 4. So again, you find the difference in your y's, difference in your x's. It doesn't matter which one goes first, but once you start with the y as whichever one you're choosing the y to be first, then the x has to correspond. So 1 minus 7 is negative 6. 5 minus 4 is 1. So this has a slope of negative 6. Now, step 2, so we found the slope. Now we need to find that y-intercept. And the easiest way to find the y-intercept is to just start with this general formula, or general form. Put the slope in, because we just found it over here. You gotta love that. all that work we did. So y equals negative 6x plus b. And you can pick one point. It doesn't matter whether you pick, and I'm going to erase all this stuff up here. It doesn't matter whether you pick this point or this point to put in for xy. I'm going to put this one in because it looks easier. This one right here. And again, remember, the first number is the x, the second number is the y in a coordinate point. So y here is going to be 1. And, ooh, you know what? Watch, I'm going to be fancy here. Oh, I'm going to try. Again, my smartboard's kind of not giving me very helpful here. And my x is 5. And we are trying to find the b. And I know my b's look like 6's, but this is what we're trying to find right here. So I have 1 equals negative 30 plus b. If I add that, I'm going to extend this page here for a minute. Ooh, look at that. There we go. I have to solve for b, so I'm going to add 30 to both sides because we want to undo that. 1 plus 30 is 31 equals b. Ooh. So there's my y-intercept. Here's my slope over here. This is my slope. And now step 3, folks, is so easy. It's putting your pieces together. Step 3 is put your pieces together. That's pieces together. Okay, so y equals, instead of m, we're going to put in that negative 6. X plus, instead of the b, is 31. Now, if you were to graph this, and we'll be doing this a lot throughout the year, if you graph this line, you would find that the 2 points, 4, 7, the original 2 points, 4, 7 up here, and 5, 1, are 2 points that are on this line. So again, first find the slope using the slope formula, then use the slope and a point to find the y-intercept, put the pieces together, and there you have the equation of the line. We'll be talking a lot about that as the week comes to a halt, okay? So hopefully this was a little bit of help for you, those of you who are a little rusty after our wonderful summer vacation. Take care.